Hey everybody, this is Ms. Harris. We're about to be going over the College Algebra Math 150 Unit 4 practice test for Ms. Meador's class. Number 1 says solve the system by graphing, and I know most of you probably like to solve for y and do y equals mx plus b, plot the y-intercept, the b, do the slope, rise over run. But when your equations are given to you in standard form, like they are here, ax plus by equals c, that's called standard form, it's actually very easy. It's easier to graph with the intercept method. So if you're finding the x-intercept, that means you're looking for x when y is 0. And when you're finding the y-intercept, that's the value of y when you let x be 0. So if you take equation 1, I'm going to label these 1 and 2. Equation 1 says x plus y equals 9. Well, if I want to find the x-intercept, I'm going to say x plus 0 equals 9. And x plus 0 is just x equals 9. Now, that's x equals 9 when y is 0. So that's actually an ordered pair, 9, 0, that you can plot on your graph. Also, equation 1, if I want to find the y-intercept, that means I'm looking for y when x is 0. So I would let x be 0 plus y equals 9. That's just going to be y equals 9. And so that's when x is 0, y is 9. So what you have right now is you have 2 points that make a line. So I'm going to go over here and plot those on the graph. Let's see, I'll pick black. So 9 zeros here, 0 9's there. And then, yeah, I'm not going to get fancy there. I thought about drawing the line. I'll just do it by hand. And that's equation 1. All right, to do equation 2, all right, let's find the x-intercept first. So in the equation 2, it's x minus y. That means we're going to let y be 0 equals 7. That's not a z, that's an equal to. And so x is equal to 7. So that's the ordered pair 7, 0. And then if I want to find the y-intercept, I let x be 0. So 0 minus y equals 7. So now you don't have y equals 7, though. This time you have negative y equals 7. So you're going to have to divide by -1 on both sides to get y equals -7. So the order pair there is x equals 0, y equals -7. So when I graph that, 7, 0 is a point, 0, -7 was a point, and there is your line. All right. Now, we're solving a system of equations where you have 2 or more equations with 2 or more variables. And where the 2 lines cross is the solution. So my solution is right there, and that is the ordered pair 8, 1. And that is the answer to number 1. All right, question number 2 also says solve by graphing. Now, I'm going to graph the first one using y equals mx plus b. Sorry. Y. Uh-oh. It's acting a little silly on me here. Sorry about that. Maybe I need to do this. So y equals mx plus b. Where m is your slope and b is your y-intercept. So in this problem, our slope is -1/2. And our y-intercept is +1. So if I were to graph this, b is where you begin. It's on the y-axis. The y-axis is vertical, so you're going to go up to 1. Now, I want you to notice on this graph, it's counting by 2s. So your y-intercept would be here at 0, 1, halfway between 0 and 2. And you're rising a -1 and running 2. So you're going to go down 1, which would be here, and over 1, 2. All right, so that's your line right there. Okay, the second equation, I could solve for y and plot the points, but I'm actually going to use the intercept method to graph this. So if I'm looking for the x-intercept, I'm going to let y equal 0. So in this problem, that's equation 1. This is equation 2. Equation 2, if I'm looking for the x value when y is 0, well, 4 times 0 is just going to be 0. 4 times 0 is 0 plus 2x equals 32. So it's like this just goes away. So really it's 2 times x equals 32, and so you divide both sides by 2 and you get x equals 16. Now that's the x-intercept. So that means the graph is going to cross at 16, 0. All right. The other point, I apologize, my markers are not cooperating with me here today. 16, 0. All right. So if I want the y-intercept, I let x be 0. So I got 4 times y plus 2 times 0 is 0 equals 32. So really you just have 4y equals 32. And when you divide by 4, you get y equals 8. Now that's the y-intercept, so that's the value of y when x was 0, so the ordered pair would be 0, 8. So 16 zeros here, 0, 8 is here. I don't know about you, but those look like parallel lines. All right, and if you count on the second line, this is the first line, this is the second line. All right, if you do rise over run over here, we go down 1. Actually, you're going down by 2, 4, 6, 8, and you run right 16. So we would go down 8 and then over to 16. That's the slope of -1/2. So the two lines have the same slope. So if they're parallel, they can never intersect, okay? So our answer is an empty set. There is no solution. Now I want to talk about independent, dependent, and inconsistent. If it's an independent system, it has one answer. One ordered pair. If it's inconsistent, there's no solution. Dependent means the two are the same line. So if we graph these two lines and they were laying on top of one another, it's like they're dependent on one another. They are the same line. So dependent means same line. Inconsistent is no solution, and independent is where you have one answer. Okay, so next question, number 4, says solve the system by substitution. Did I skip one? Hold on, let me back up. I sure did. Let's go back to number 3 here, my bad. So on number 3, it says solve the system by substitution, determine whether the system is independent, dependent, or inconsistent. So it wants you to solve by substitution, which is nice because you'll notice equation 1 up here. Let's undo that. Whoa. I love technology. Sarcasm. All right, so this is equation 1. This is equation 2. You'll notice equation 2 already has x equals stuff. So that's what x equals. So we're going to plug that into the first equation where there was an x. So we have 8 where there was an x. We're going to put parentheses plus 4y equals -40. All right, and instead of x in 8x, we're going to substitute in what x is equal to, and x is equal to 9 minus 4y. All right, so we need to distribute. So 8 times 9 is 72, minus 8 times -4 is -32y, plus 4y equals -40. All right, we're going to combine like terms and we got to solve. So these two are like terms. We're going to bring down 72. -32 plus 4 is -28y equals -40. Okay, and to solve for y, we're going to subtract 72, and we bring down our -28y. -40 minus 72 is going to be -112. And then to get rid of the -28 is attached by multiplying, so we do the inverse operation. We divide by -28, and we get y equals, I don't know. What does y equal? Y equals 4. Positive 4. Now, you know y, but now we got to find x. So to find x, look at your two original equations. The best one to use is the one that says x equals. So we're going to say x equals 9 minus 4 times y, and we now know that y is 4. So you'd multiply first. Negative 4 times 4 is negative 16, excuse me. And so x equals negative 7. So you just found an ordered pair, an x and a y value that makes both equations true. Negative 7, positive 4. That is the solution to this problem. Now, because there's one answer, that's called an independent system. Okay, question number 4 says solve by substitution, determine whether the system is independent, inconsistent, or dependent. Well, the first thing I noticed is they're both in y equals mx plus b form. And they have the same slope. Sorry, hold on just a second. All right. So they have the same slope. And if two lines have the same slope and different y-intercepts, okay, the same slope but different y-intercepts, those two lines are parallel. Parallel lines never intersect. So empty set, and it's inconsistent. If you were to set them equal to one another using substitution, you would have said 3x minus 8 is equal to 3x plus 3 because y equals y. Well, watch what happens when you try to solve for x. You subtract 3x here, you subtract 3x there, all the variables disappear. And when the variables disappear, something special is happening. And because we get negative 8 equals 3, we know that that is false. It will never happen. And if it never will happen, it's no solution. Now, let me tell you what, if you had set them equal to one another and you had gotten a true statement like negative 8 equals negative 8 or 3 equals 3, then that means there's infinitely many solutions because the two lines are laying on top of the y-axis. And the solution set would have been y equals whatever y equaled in the problem. And that would have been a dependent system because it would have been the same line. All right, question number 5 says, solve the system by addition, determine whether the system is independent, inconsistent, or dependent. Now, first thing I want you to notice is they look like they're in standard form, but the second equation is actually not in standard form. So I want to rewrite, I'm going to bring the first equation over here, just rewrite it like you see it. But the second equation, x should be first, y should be second, equals 5. Now, we're going to add vertically, and look what happens. When you add vertically, 9x minus 9x cancels, negative 6y plus 6y cancels, you get 0 equals 15. So all the variables disappeared, which is what I just talked about in number 4. So if this is a true statement, we have infinitely many solutions, but this is a false statement, therefore there is no solution. And that's an inconsistent system. All right, question number 6. Most people don't like word problems. The question on your test will look exactly like this with just different numbers. So we've got to make the words into sentences. So it says, Miss Wilson invested $25,000 in 2 accounts, one yielding 6% interest, the other yielding 9%. If she received a total of $2,070 in interest at the end of the year, how much did she invest in each account? So the question tells you what your variables are. How much did she invest in each account? So let's let x equal the amount, let's see, the dollars, we'll say invested at 6%. And let's let y equal the amount or the dollars at 9%. Now you have 2 unknowns, so you need 2 equations. So first of all, she invested $25,000. So if you took the amount at 6% plus the amount at 7 or 9%, That's a total of $25,000. So that's my first equation. I'm going to have x plus y equals 25,000. All right. My second equation is going to be about percentages. So I got one at 6%, one at 9%, and that's interest. And the interest she received was 2,070. So 0.0, sorry about that. 0.06 times x, because that's the amount she's invested in the 6% account, plus 0.09 y, because that's the amount of money she's invested at 9%, is equal to $2,070. And you have to do 0.06 and 0.09 because that's a percentage in the problem, but we have to change the percentage to a decimal. So you move the decimal left 2 places. Bless you, that's my dog sneezing. All right, so I got 2 equations. You can solve by substitution or elimination. I'm going to choose elimination. This is equation 1, this is equation 2. I wish I had room to work left or right here. I need to make either x or y disappear. So I'm going to take the first equation and multiply by negative 0.06 to every single term. If I do it to one term, I have to do it to all of them. So it's sort of like distributing that 0.06 at negative 0.06 to all of them. And I'm going to write what it's multiplied underneath here. So I'm going to have a new equation 1. I'm going to call this equation 1a. All right. So I'm going to multiply by negative 0.06, and I got negative 0.06x. All right, now I got to do negative 0.06 times 0.09. And I get negative 0.0054y. Oh, I'm sorry, back up. That didn't happen. Take all that off. Now this is why you got to be careful. This is why I normally work left or right on this. I'm multiplying the first equation, not the second equation. So negative 0.06 times x minus 0.06 times y. Now I have to do negative 0.06 times 25,000. And we get negative 1,500. Okay? So really, I'm done with equation 1 for now. All right? And I want to add these 2 equations vertically and use elimination to solve. So 0.06x and negative 0.06x are going to cancel. All right. 0.09 minus 0.06 is going to be 0.03 y. And 2,070 minus 1,500 is going to be 570. Now what happened was we just eliminated the x, so now we can solve for y. So when I solve for y, all right, I'm going to divide by 0.03 and divide by 0.03. And 570 divided by 0.03 is $19,000. Now be careful. That's how much Miss Wilson invested in the Y account. The Y account is the 9% account. All right? So 9% is $19,000. Now we know she invested a total of $25,000. So if you use the equation x plus y, x we don't know plus y we now know is 19,000. We know that equals 25,000. So you could just subtract the 19,000 on both sides, and 25,000 minus 19,000 is $6,000. That's a 6. And that is question number 6. All right, question number 7 says determine whether the given points is in the solution set to the given system. So it's given you an ordered pair. Remember, an ordered pair is x, then y. It's in alphabetical order, x, y, z. All you have to do here is plug it into each equation. If it makes both equations true, you have a solution. If it makes one equation true but not the other, then it's not a solution. I'm going to plug it into the first one first. So 8 times x. Here we have x as being negative 2, minus y is 6, equals negative 22. Actually, what we were asking ourselves is, does it equal negative 22? So now you could type all this in the calculator. That's going to be negative 16 minus 6. That is negative 22. So it works for the first equation. All right. Now let's try it in the second equation. Y, well, y is 6. 6, does 6 equal x squared plus 2? But we got to fill in x's value. X in our ordered pair is negative 2. So negative 2 squared is 4. 4 plus 2, look at that. It does equal 6. So it works in both. So the answer is yes. All right, question number 8 says solve the system algebraically, then graph both equations on the same coordinate system to support your solution. Now there's a couple of ways we can do this one. I'm going to try to show you on the graphing calculator because I think it's the easiest. So on your graphing calculator, you're going to go to y equals screen, and you're going to type in the first equation, x squared. And then we're going to go down here to the y2. Now, notice it has to be y equals to use this. So we got to solve the second equation for y. All right. So, of course that messed up. One moment. Let's see, let me try this again, y'all. Try it again. There we go. All right, so to solve for y, I'm going to I need to move this 7x to the right, so I'm subtracting 7x on both sides. The screen's being very touchy. So in the second equation, I subtract 7x on both sides. That leaves me with negative y equals negative 7x plus 10. And then I got to divide by negative 1 to get y by itself, but you got to divide everything by negative 1. So negative 7 divided by negative 1 is 7. 10 divided by negative 1 is negative 10. So we're going to type in our equation 7x. Got to change to select. 7x minus 1. Now when you graph, you should always go zoom 6, zoom standard, because that puts you in a 10 by 10 window. There's your parabola. And there's your line. Now, it looks like it's only crossing one place right here close to the origin. But actually, if you zoom out, number 3, and press enter, you can see the line's going to actually cross in 2 different places. Okay? Now, I don't know if y'all are familiar with using the table on the graphing calculator, but if you hit second window and set your table, let's just start at like negative 2 with a change of 1. Delta, that little triangle delta table means change in table. So before you go to table, you should set your table. So second window, set your table. And then when I'm going to hit second graph, now remember our y1 is our parabola. Okay, and our y2 is our equation of our line. Now I'm looking for y values that are equal to one another, and I'm not seeing anything nice. Okay, I'm not seeing nice numbers. So it looks like we are going to have to do this algebraically. So let me minimize this. All right, and algebraically, we're going to take what the first equation, we're going to take the first equation, what y equals there, it equals x squared, and we're going to substitute it in for y right here. So in the second equation, I have 7x minus y, well y is x squared, equals 10. Now this is a quadratic equation. So I have to set it equal to 0 and probably factor. I don't know if y'all factor this year or not, I can't remember. So first thing, I'm going to put negative x squared out front, positive 7x second, and then I want to move 10 to the left so it becomes negative 10. Now, I don't like to factor when my leading coefficient is not positive, so I'm going to factor out a negative 1. Technically, you're just dividing everything by negative 1. Let's just do that. So let's divide everything by negative 1. So negative x squared divided by negative 1 is positive x squared. 7x divided by negative 1 is negative 7x. Negative 10 divided by negative 1 is positive 10. 0 divided by negative 1 is 0. So if you factor that, you're going to put an x here and an x here. You're trying to multiply to get positive 10. Either they're both positive or they're both negative. So things that multiply to give you 10. 1 and 10, 2 and 5. And since the middle sign's negative, we want them both to be negative. So they got to multiply to get 10 and add to get 7. That's going to be 2 and 5. So we have x minus 2, x minus 5. Now you should FOIL that to check to make sure your answers work. So x times x, x squared. Your outers are negative 5x, your inners are negative 2x, that's negative 7x, and your last times last is 10. So that does work. Now when you bring them out of the parentheses, x equals 2 and x equals 5 should be the two x values that work on this graph. Alright, so if x is 2 and 5, let's find the y values for those two different ones. Y is equal to x squared. So if x is 2, y is going to be 4. That's the ordered pair 2, 4. And if x is 5, 5 squared, y is going to be 25. So when x is 5, when x is 5, y is 25. My handwriting is atrocious. Now, that solution set should work for both graphs. Let me see if I can pull up the graphing calculator again. I just noticed what I did. This is why we didn't see any common numbers a while ago. When I solved up here, let me minimize that. When I solved for y right here, I bet some of you were thinking, what happened to the 10? Yeah, that's why the problem didn't work. When I divided everything by negative 1, I forgot to do that. So now hopefully this will make more sense now. I bet I could have just looked at the table to begin with. So let's drag this over here. And let's change my equation. That should have said 10. Now if we look at our table, you're looking for x's and y's that match. Look at that. When x is 2, y is 4 for both graphs. That's what we got over here, 2, 4. And if we arrow down, when x is 5, y is 25. And if we go back and look at that graph, and it's hard to see. Let me go back to zoom standard. Since I've changed my y-intercept, it might look differently. See, it still looks like it's only crossing once, but it's actually crossing twice. So when you have a parabola in a line, it's going to cross twice 99% of the time. All right, so those are my two answers right here. And that is question number 8. All right, question number 9 says graph both equations to support your conclusions. Oh, we're supposed to solve it first. Now, this problem will always, it's the square root of x. If you took pre-cal, you should know square root of x looks like this. So immediately I know B is not the answer. It's either going to be A or C. And then I'm going to graph y equals 6x, which goes through the origin and has a positive 6 slope. So which one is the answer? It's got to be C. All right, and we're going to look at our calculator as well. So let's pull up the calculator. All right, so I'm going to go to my y equals screen. I think I can do this up here. Yeah. So y equals the square root of x. And then I want to do y equals 6x. So I'm going to clear 6x, zoom standard. Now, it looks like they only cross once. See, when you're looking at that, it only crosses once. Well, look at this. Look at the graph that they gave you. It has been zoomed in. It has been zoomed in. My dog is eating something at school. I don't know what he's got in his mouth. All right, so if you zoom in on that, zoom number 2, and press enter, Still looks like 1 point, but there's actually 2 points where they're congruent. Now, I don't know if you know this on your calculator, but you can find an intersection of two graphs on your calculator. If you do second calculate, you never trace, by the way, you always calculate. Number 5 is intersection. So I know 0, 0 is an answer, okay? And we'll talk about that in a minute. Oh, dang, hold on. But I want to go to the right. I did second calculate number 5 intersection. I'm going to go to the right and go past that intersection point and press enter once. It jumps to the second graph, enter twice, and you hit enter a third time to calculate. And that is the answer. Now, I don't know if you noticed, but 0.027777778 was probably 0.027 repeating, and it rounded it up. So I want to write that up here for a second. 0.027 repeating, and y is going to be 0.16 repeating. Now, if it wants exact answers, that means we can trick our calculator to do that. Watch this. Hit second quit. Oh, got to go back to select. Second quit. And if I do 0.02777, if I go all the way to the end, all right, and hit math, enter, enter, it'll change it to a fraction for me. 1/36. And then if I go back and I type in 0.16 and go 6 all the way to the end of the screen, you can even go a little further, math, enter, enter, you get 1/6. So you have 2 points where these graphs cross. We have 0, 0, and we have the ordered pair 1/36, comma 1/6. Now, if we had done that algebraically, you would use substitution. Y is equal to y, so you would take what y equals here and plug it in right there. So the square root of x is equal to 6x. And to get rid of the square root, you would need to square both sides. And the square root and squares cancel, leaving you with x. 6x times a 6x is 36x squared. And if we move this x over here and set it equal to 0, we have 36x squared minus x. You could factor out an x, and that would leave you with 36x minus 1. And you have a product. You have something times something is 0. So one of those has to be 0. That's called the zero product property. So x could be 0. That's a solution because 0 times anything is 0. Or when does 36x minus 1 equal 0? Well, you would add 1 to both sides, and you would divide both sides by 36, and that's how we got our two x values. So in one ordered pair, x is going to be 0, and the other ordered pair, x is going to be 136, because these two, the curve and the line, cross twice. Now, how do you get the y value? Well, you plug your x's back into one of your equations. I'm going to plug it into this second equation. So if I take y equals 6 times x and x is 0, I get y equals 0. That's why that point is a solution. If I let x be 1/36 and I use the second equation, y equals 6 times whatever x is, 1/36. That becomes 6 times 1/36 is 636, which reduces to 1/6. And so your ordered pair is 136 and 1/6. Okay, so here's your solution. The graph part is the easy part. Good luck on that one. Okay, question number 10 says solve the system algebraically, then graph both equations on the same coordinate system. I actually think the graph is super easy first. We did conic sections last unit. That's sections of cones. Equation 1 is a circle. It's a circle that has a center of 0, 0, because there's nothing attached to x and nothing attached to y over here, like x plus 2 quantity squared or something like that. And the radius is 3, because remember the standard form of a circle is x minus h quantity squared plus y minus k quantity squared equals the radius squared. So everything is squared even though it's a circle. So since nothing is up here with x or y, the center is 0, 0, and r squared is 9, therefore r is 3. So I'm looking for a circle that has a center of 0, 0. The only one that has that is this one. But we got to solve for the actual points. You can tell it crosses, the line crosses the circle in 2 points, right here and right here. But those are probably not going to be nice answers. So let's solve the system. So we got equation 1 labeled equation 2. It tells you what y is equal to. So I'm going to plug that into the first equation where there is a y. So equation 1, we have x squared plus whatever y is squared equals 9. We know that y is 3x. 3x. So if you square that, 3x times a 3x, that's 9x squared. All right, so over here on the left, I got like terms. 1x squared plus 9x squared is 10x squared equals 9. You're going to divide both sides by 10. And you get 9/10. And then the opposite of square is square root. So you square root the left and square root the right. Square root and squares cancel. Now what you got to remember is when you take a square root, you can get a positive answer or a negative answer, plus or minus. The square root of 9 is 3, but the square root of 10 cannot be broken down. And I'm not sure, but she's probably going to want you to rationalize that. So you would multiply the top and the bottom by square root of 10 to get rid of the radical in the denominator. So you have two x answers, plus or minus 3 radical 10, because 3 times radical 10 is 3 radical 10. Square root of 10 times the square root of 10 is the square root of 100, which is just 10. Another way to look at that, you got a square root of 10 and you're multiplying it to itself. You're squaring it basically. So the square and the square roots cancel, leaving you with 10. Now you have two x values. How do you find the y values? Okay, well we have an equation 2 back up here. Y is equal to 3 times whatever x is. So y is going to be 3 times the positive 3 radical 10 over 10. That's going to be 3 times 3 is 9 radical 10 over 10. Okay, so when x is positive 3 radical 10 over 10, we have our y value. So that's our first order pair. 3 radical 10 over 10, comma, 9 radical 10 over 10. That's the first point where they cross. Now the second point, you're just going to plug in negative 3 radical 10. So look, that's an easy fix. You're going to take this equation, and instead of doing a positive, you're multiplying by negative. So then your answer is going to be y equals negative 9 radical 10 over 10. So your second ordered pair, which you're going to separate with a comma, is negative 3 radical 10 over 10, comma, negative 9 radical 10 over 10. So right there are your 2 points where the line and the circle cross. The graph is the easy part.